So this is tutorial number 10. Figure Q.2 here shows a flat plate 3 times 1.5 meter is held in water moving at 5 meter per second parallel to its length. Determine the power required to overcome the drag. Take the value of rho and mu as stated here. And this question also gives you the value of CD lamina and also the CD turbulent. So for boundary layer, okay, you need to know that it's actually not influenced by the direction. So means if your location is like this, so it's you still need to solve this situation, okay, by using the same idea of this question. Even though, for example, your plate is like this, okay, decrease with a certain angle here. So if the flow here is parallel with the plate, so there are no changes in the solution unless you are the flow is horizontal like this and your object is inclined at certain angle like this, then you need to do some integration. Okay, this not actually not the syllabus of for fluid mechanics too. Okay, so this is the question. Okay, let's say this is the situation. We have the U here. So this is the length, this is the width. So another rule of thumb means hint or tips that you need to know is, please make sure that you really know where is the length and where is the width. Because sometimes maybe the location is like this, but if the flow is come from bottom to the top like this, so you need to understand that the length, the x here is 1.5. So if the flow is from right to left, so the 3 meters will become the length. Okay, because normally people will say that, okay, if the situation is like this is always the length, this is the width. Because normally we could say that the length is longer than the width. Okay, that's not the idea in boundary layer. Okay, because okay, you need to make sure that your calculation is perfect. Okay, the idea is simple. So let's say we check the Reynolds number. So we check it is turbulent, which is 1.5 here. So turbulent. So and then we check the Reynolds number at transition. So we need to understand the whether the laminar boundary layer is dominant or not. So we found it is 0.1%. So means that it is just 3.3% from the total area. So means that we could say that the laminar boundary layer can be ignored. So what means ignore here is you could assume that the total boundary layer that occur on that situation is fully turbulent, means 100% turbulent. So from the question, we know that the CD for turbulent is given like this. So and then if we substitute the value of Reynolds number, we could get it is equal to 2.71 times 10 to the power of minus 3. So and then we substitute into the equation, so we could get this one. So it is 152.4 newtons. So here, what you need to understand here is this amount of force is actually only considered the one side of the plate. So if your question asks you to calculate the total force, so means that you need to times 2, because at the bottom here, the same amount of resistance was occur. So you need to times 2. So again, for example, if you have a four-sided like this, so actually there are 4 sides that have boundary layer, and you also need to calculate the drag force due to the front surface. Okay, please imagine this situation. Okay, so this is the idea, as I said. Okay, so and then because boundary layer occur at both surface, so means the top and the bottom one, so means we need to times 2. So we get the total force is 304.8 Newton. So, and then this is the important equation that you should know. Sometimes people in a mechanical engineering world will use in term of power. Okay, as we learn in, we will learn about pump and turbine again in fluid mechanics too. So I think in fluid mechanics 1, we already learned about the major losses, and sometimes we express the power of pump, or uh, the capability of pump to transport water in terms of power. So the equation of power and force can be written as this one. Means power is force times velocity. So in this case, the force is actually the drag force. So means if you want to express this resistance in terms of power, you could write 304.8 times 5, because the velocity is 5. Now you will have 1524 watt. Because sometimes in our syllabus, in our test and final exam, we will ask you in terms of power.